regular second year. My topic is wires, cables, and electric wires. These are the materials used for transmitting electric current from one point to another point. We know uh, materials are classified based on materials are three types: conductors, insulators, and semiconductors. Wires are basically conductors. Wires can be further classified based on material, m- making based on the material they are made up of, based on the insulation, based on the usage of the wires, based on material. Copper wire. These are the wires made with material copper. These are highly conductive, durable, and corrosion resistant. Applications are residential wiring, power grids, electronics, and telecom. Aluminum. Mostly these are used due to their special factors such as lightweight and their cost effective. But also they have a drawback of less conductivity. Application overhead power lines, industrial cables, automotive, and AC. Other materials like gold, silver are also made for using wires. But these are highly costly and rarely available. Based on insulation. We know wires are covered with plastic, rubber, PVC, and thermoplastic for protection against electrical faults and hazards. These are insulated wires. Uh, Applications are residential and commercial wiring, power distribution systems, electronic circuits. Types of insulating materials are polyvinyl chloride, rubber, XLPE. Based on usage. On usage, it has power, control wires, communication wires, signal wires. Power wires are used to carry electrical power through various devices and systems. Control wires are used to control the operation of devices or systems, typically in automation. Communication wires transmit data, signals, and information. Okay, and the last one is signal wires, used for transmitting signals between devices. Uh, Basically, this is the cable structure. It has a core, PVC insulation, oil duct, metallic screen, and rubber insulation. Cables. Cables are nothing but a bundles of chemical conductors or bundle of wires together made is called cable. These are used to transmit electrical power, signals, or data from one point to another. Types of cables. Cables can be classified based on shape, based on mechanical protection, voltage rating, installation, insulation material, and application. Based on flat cables. These have a flat structure. They are very thin and flat structures. They are easily breakable. And round cables. We know regular usage of cables. We see regular in life. Normal cables. These are the cables which are placed internally, and these are the cables which have very less chances of physical damage. They are connected in a place where the physical damage occurring to it is very low. Probability is very low. Armor cables are like regular cables, which are covered which are covered mechanically for extra protection, such as silver or tape, making them suitable for our engine mount. Voltage rate. Based on the voltage we are sending or the signals, the cables are divided into low voltage cables, high voltage cables, super tension cables, extra high tension cables, ultra high voltage cables. Low voltage cable up to 1000 volts, high voltage cables 11,000 volts, super tension cables 132 kilovolts, extra high tension cables 132 kilovolts, ultra high voltage cables 400 kilovolts and more. Insulation based on the insulated material like such as PVC, XLPE, rubber, paper based on application. Same as well as power cables also has different applications such as power cables used for transmitting electrical power, control cables for industrial control system, instrumentation cables used for signal transmission in process industry, communications cables, and fire resistant cables. Differences between wiring cables are wire is a single conductor. Cable is a collection of multiple wires. Uh, Wire is made up of one or more materials, but cable is consists of two or more wires, which often insulation and protective wires. Wires may or may not have insulation depending on the type. Cables are typically insulated, often with they have multiple layers of for protection. As they transmit heavy data, they are highly protected. Wires are used for low power transmission. Cables are used for highly networks and signal transmission into industrial machinery, etc. Wires are generally flexible. Cables are more flexible as they are very useful. They are made with heavy usage of very regular materials which have heavy flexibility. Wire handles very low voltage. Cable can handle very high voltage, as we have seen, can handle up to 400 kilovolts. Earthing. Earthing or grounding is a process for connecting electrical systems or equipment to the ground to prevent electrical shock. It provides a safe path for electrical current to flow into the earth in case of a fault, ensuring the protection people and equipment. Basic example is whenever a thunderstorm happens. Suppose the thunder has fallen onto your house, but there will be no change in your, there will be no problem in your electricity because during the construction of house, we place an electrical copper rod above the house, which is connected another rod in the soil. So it helps. So it does not it the whole electricity is conducted into the earth. Types of earthing: rod earthing, plate earthing, strip earthing. See, this is example of this is rod earthing. A rod is inserted into soil. This is plate earthing. Same plate, strip earthing. Types of earthing: plate earthing, rod earthing, strip earthing, shallow earthing, chemical earthing. Plate earthing. A metal piece will be vertically buried into the ground to that conduction electrical system, the earth, ensuring for safe discharge and fall currents. Components are metal plate, which is made up of copper galvanized iron. Advantages: it has low resistance and fault current fault current dissipation. It is long lasting and durable. Provides safety by preventing electrical shock. It requires disadvantages are it requires particular soil conditions and requires more space. Uh, and it is highly suitable for places with soil high soil resistivity. Applications are substations, industrial plants, large buildings. Rod earth. It is nothing but a rod. Inter is buried 3 to 5 meters in the ground. Materials are made of copper or galvanized iron. At connection, the rod is connected electrically, so that the electrical faults are directly conducted into the earth. Advantages are simple and cost effective, suitable with suitable for the locations, slow soil resistivity. Requires less space compared to later. Disadvantages: may not be effective in high soil resistivity soil without additional materials. No problem. When there is when the soil is highly resistive, we need to add additional materials for more effectivity of this rod earthing. Limited surface area, commonly used for residential and small scale commercial electric system. Strip earth. Strip earthing uses a material buried horizontally in the ground to connect the electrical system to the earth for fault current dissipation. Metal components are metal steel, typically copper and galvanized steel, laid in a trench. Hmm. So this is the example, basic diagram of it. Okay, then installation: a trench is dug and the metal strip is laid along the trench at a depth of 0.5 to 1 meter. The strip is then connected to the electrical system for earthing. Advantage: provides a larger surface area for effective fault current dissipation, suitable for areas with higher soil resistivity. Shallow earthing. Mm, Shallow earthing involves placing the earthing connector into a shallow trench, usually at a depth of 0.5 to 1 meter, to connect the electrical system to the installation. A shallow trench is dug and conductor is placed inside. The trench is then backfilled. Advantages: simple and cost effective, suitable for locations where soil conductivity is given. Disadvantages are Uh, Not effective in high soil resistivity. Shallow depth may not be suitable for all environment conditions. Typically used in smaller installations or areas where soil conductivity is favorable. Chemical earth. Chemical earthing uses a mix of chemical compounds like salt and charcoal to lower soil resistance and enhance the effectivity of earthing system. Because in chemical earthing, we use compounds like salt and charcoal and other chemicals to reduce the soil resistance. Um, Components are electrode, which is made up of typically copper or galvanized iron rod. Chemical mixture is a combination of salt, charcoal, and sometimes other chemicals. I think then the electrode is placed in a pit filled with chemical mixture. Okay. Installation. The metal rod is inserted in the ground and a mixture of chemicals is placed around it to improve conductivity. First, the metal rod is inserted, then the chemicals are placed around it to improve its conductivity. The pit is again backfilled with chemical compounds to improve the reduce the soil resistance and improve the earthing performance. Advantages: effective in high areas with high soil resistivity, such as rocky or dry regions, improves conductivity and ensures a low resistance path for fault. Disadvantages: requires periodic maintenance to replenish the chemical mixture. Okay, we need to regularly, periodically maintain it. Like we need to change the chemical mixture regularly. Installation can be more expensive than conventional earthing methods. Okay. Applications used in areas with poor soil conductors such as dry or sandy regions and in high resistance environments. This is the basic image of chemical earth. This is silver electrode and this is silver and this is copper. Thank you. I'm Manohar.